Hello guys, welcome back to Mathematics. Today we're going to learn about ratio and proportion. And this topic is easy to explain through some examples. So let's think about this necklace. This necklace has red and black beads. And do you see these points at the edges? That means that it keeps going, so we don't really know how many beads the necklace has. But notice that we can see a pattern. There's three red ones, two black ones, three red ones, two black ones, and so on. So what we know so far is that there are three red beads for each two black beads. So from that, we could establish two things, ratio and proportion. The big difference between these two, ratio and proportion, is that the ratio is a relationship between parts of a total, part to part. And the proportion is the relation between a part from the total. So in this case, since we have just red and black bits, we are just going to be able to establish two ratios, red to black and black to red. We can also write it like this, red, two dots, black. And this one, of course, black, two dots, red. Okay, in this first one, since it says the ratio red to black, so we are going to put the number of red bits first. So we would say the relation red to black is 3 to 2. Because for every 3 red bits, there are 2 black bits. And the opposite, if we establish the relation black to red, then we would say there are 2 black bits to 3 red bits. That is what we call ratio. Now let's check the proportion. It says that it's a relation between part and the total. So in this case, we have red and black bits. So we could establish two proportions. The first proportion is red from the total. And the second one is black from the total. So this is about how many red bits we had from the total of bits. We don't know the total of bits, but we can have kind of units of proportion. So we know that this is the pattern that we repeat over and over again. So we would say the total is 5. And from those 5, 3 are going to be red. So we could write this as 3 out of 5. And this we can actually express it as a fraction, 3/5. Remember, a fraction also means 3 out of 5. So that's why we can write a proportion as a fraction. And now, in order to check the black from the total, we would say that it's just 2 out of 5. Or as a fraction, 2/5. So here is when I want you to take a lot of attention because the big difference is the ratio is part to part. Now this is 3 to 2. It doesn't mention the total at all, but the proportion is from the total. So the denominator of the fraction is always going to be the total of the unit that we are analyzing. So we have a unit of 5 bits, so the denominator is always going to be 5. And the number that is going to change is the top. If we are talking about the red, then it's going to be 3, and about the black is going to be 2. And in the ratio, it matters the order. Red to black is 3 to 2. But if we talk about black to red, then it's going to be 2 to 3. Very important, guys. Then what happens if we change some of the bits and now there's going to be 2 reds, 1 green, and 2 black ones? In that case, there are more ratios that we could establish, right? Because we could say red to black, but we could also say red to green, and all the combinations, black to red, black to green, we have a lot of them. And actually, we can also establish a ratio between the three of them. We could say red to green to black. So we could include as many as we want. It's just that usually we just need to find the ratio between two of them or even three of them. But how do we write those ratios? Red to black, it would be 2 to 2, because there are two red for each two black bits. And you might be thinking that we could write this 1 to 1. Is that possible? Yes, that's possible, because we could also say that for each red, there's one black. And that is true because we have the same amount of black than red. The ratio red to green, it would be 2 to 1. The ratio red, green, black, it would be 2 reds to 1 green to 2 black. So notice that we have a lot of different ratios that we could establish. I put just 3 here, but there's a lot of different combinations. The proportion is different because it's from the total. So we could just do red from the total, green from the total, or black from the total. So the 5 is going to be at the denominator. We have 2 reds, 2 out of 5. Green, we have just 1, so 1 out of 5. And finally, the black, 2 out of 5. Okay, so notice that when we talk, for example, the proportion of red, it doesn't matter how many green or black ones we have. It just tells us about the presence of red. The ratio is something similar. It's just about the ones that they are mentioned here. So we couldn't know how many greens are if we have the ratio red to black. So it's all about the information that we have and the information that we want. So as you could see, with both ratio and proportion, we can simplify. So for example, for this, we could divide by 3 both numbers and say that a ratio 3 to 15 is the same as saying 1 to 5. And in this one, we could actually divide everything by 2 and say this is equivalent to a ratio 1 to 2 to 14. The proportion, since it's a fraction, of course, we can simplify it too. We could divide, for example, by 2 and 1 out of 4, 1/4. It's the same as a proportion of 2/8. In this one, we could divide by 5 to get 1/4. So notice these two proportions are actually equivalent. Now let's check how to apply this in some examples. The first one says, Sarah has a recipe for 6 people that says to use 2 eggs for each 5 cups of milk. If Sarah is cooking for 9 people, how many eggs and cups of milk should she use? So in this one, we could establish a ratio between people, eggs, and cups of milk. The relation is 6 to 2 to 5. But we actually need 9. So notice if we divide 6 by 2, we get 3. And then we could multiply by 3 to get the 9. So we are basically finding equivalent ratios that is going to give us the right proportion for 9 people. So first we divide by 2. So it's going to be 3 to 1 to 2.5. And now since I want the people to be 9, I'm going to multiply by 3 to get 9, 3, and 7.5. That means she should use 3 eggs and 7 cups of milk and a half to get the recipe correct. Let's check the second example. The proportion of boys in the classroom is 3/5. If there are 10 girls, how many students are in the classroom? Okay, the proportion of boys is 3/5. 3 out of 5 proportion of boys. That means the proportion of girls is the remaining fraction. So if the total is 5 and there are 3 boys, that means there are going to be 2 girls for each 5 students. So the proportion of girls is 2/5. Now, all we need to do is to find an equivalent fraction where the top is 10, since there are 10 girls in the classroom. So whatever is in the denominator is going to give us the total of students. So yes, we need to multiply by 5. 2 times 5 is 10, and 5 times 5 is 25. So a proportion of 2/5 of girls is equivalent to 10 out of 25. That means the total of students is 25. Let's check this third example. It says, in a zoo section, there are tigers and lions. If there are 3 lions for each 4 tigers, and there are 35 animals in total, how many lions are there? Okay, so we can establish a ratio between lions and tigers. It says for each 3 lions, there are 4 tigers, so the ratio is 3 to 4. For each unit, we would have 7 animals in total. Now, they are telling us that there are 35 animals in total, so we could multiply the 3 numbers to find an equivalent ratio that has 35 animals in total. So from 7 to get the 35, we should multiply by 5. So we do the same in all of them. 3 times 5 is 15, and 4 times 5 is 20. So the equivalent ratio would be 15 to 20 to get the 35 animals in total. So we already know that there are 15 lions in total. And that's how we apply ratio and proportion in some problems, guys. Okay guys, I hope it was useful. Don't forget to subscribe to my channel, book your own lessons with me if you want, and drop any questions you have in the comments box. Bye bye guys, see you next time.